So at a couple of points in this course, we've talked about CORS and said, don't worry about it, we'll talk about it later. Well, that time is now. So what is CORS? CORS stands for Cross-Origin Resource Sharing, and it allows you to use resources from other sites in your site. So for example, in the site that we're building for our chat application, it needs to access resources from a bunch of different AWS servers. How do we do that without triggering a bunch of security errors and warnings in our browser? CORS to the rescue. Now, it might seem to be pretty basic, but it's actually a lot more complicated than you might think. So let's dive into an example. Gather around the fire while Uncle Frank tells you a story. Long ago on the internet, when AJAX was first becoming a thing, and as a reminder, AJAX is an acronym for asynchronous JavaScript. It's just a way of actually fetching resources dynamically in a web page from some web server. So when that was first becoming a thing, they put some restrictions on it. Namely, they created the same origin restriction, which meant that you could only make AJAX requests to the same origin as the page that was making the call. And there's a good reason for this. You don't want web pages sending your personal data off to other sites without you knowing about it, right? That can be kind of sketchy. So in this example, we have a website called foo.com, and it has an image tag in it that loads an image from bar.com. It also has a script tag in it that loads JavaScript from baz.com. So that JavaScript then might attempt to make an AJAX call to baz.com, and the browser doesn't allow it. Unless the request goes to foo.com, the browser would immediately reject the call, sometimes without even showing an error. It would just not work, and you wouldn't know why. This meant that you would have to do all sorts of work to make it look like any remote resources were actually hosted on your server on foo.com. People would create proxies within their servers to try to make that happen and all sorts of silly stuff. But then, someone got clever. They realized there might be a way around this. Now, the idea when the XML HTTP request was created was that it would fetch some XML from a server. It was XML because it was the 1990s and XML was the answer to everything back then. So rather than having the server produce XML, it could produce JSON and wrap it in a call to a JavaScript function. Then on the web page, the JavaScript would create a new script tag in the DOM, the document object model, causing the browser to load, parse, and execute the dynamically built script that came back from the server. So suddenly you could get data passed directly back into a callback. This method of cross-origin sharing is called JSONP, JSON with padding, where the padding is the call to the callback. Now, it's good because it will work with almost any browser made in the last 20 years or so, but unfortunately it's very limited. You can only do GET requests, so all the data you pass to the server has to be in query parameters. Also, you end up adding a lot of stuff to your JavaScript environment and your document object model, your DOM, if your page is sufficiently complex. And really, JSONP gets pretty messy after a while. So, as usual, the solution is a new standard called CORS. Now, instead of the browser flatly refusing to make the request, it might make it. So how does the browser make this decision? Well, the first thing it might do, assuming this is a brand new page and the browser thinks it's important, is to make a pre-flight request. Most browsers will not do this for GET requests. The pre-flight request is an options request as opposed to GET or POST or PUT, and it has a few headers in it. One is the origin. This is the domain with scheme, that's the HTTP or HTTPS of the page that's making the request. Next is the access control request method. That's the method that the browser wants to use, GET, POST, or PUT. And access control request headers. These are the headers that the browser wants to use. Now, you can do a lot of interesting things with the response, but most people make it fairly static. It has a bunch of headers it can provide, including access control allow origin. This is the origin that should be allowed. It can be only one value. It can't be a list. And the only acceptable values to the browser are the same value as the origin header in the request, or a star, meaning that any origin is allowed. Next is access control allow methods, and those are the methods that are allowed. Next, we have the access control allow headers in the response, and that's the list of allowed headers that can be passed. We have access control max age, and that allows the server to say how long the result of this call might be valid for. And finally, access control allow credentials comes back in the response. Credentials are basic HTTP auth credentials and cookies. So if you rely on cookies for your API, which I don't recommend, you'll need to make sure that's set as well. Now, once the browser receives this response, it will cache it for that URL because different URLs can have different policies, even if they're on the same server, and determine if it's valid. If it is, it will make the request. So then what? Well, when it makes the request, in this case a GET request, it will still provide the origin header and expect an access control allow origin header that either matches or is a star. And if those conditions are not met, the browser will fail the request. So it's all very complicated, and mind boggling, but let's just dive in and get our hands dirty and see how it actually works in practice. So roll up your sleeves, we're going hands-on again, go back into the AWS console. I've already logged in here, and we're going to set up CORS on our API for our little chat application right now. So start by clicking on API Gateway, or typing it in to search for it if you need to. And we'll select the API that we made for this course, the Chat API. And now we're going to click on the proxy resource and go to Actions and say Enable CORS, Enable Cross-Origin Resource Sharing. And let's go through what's going on here. So we want to enable CORS on 400 and 500 responses. That way we'll get the proper headers back on both success and error responses. And since we're going to be using a proxy, the only method that CORS configuration can be applied to is options. Later we'll start breaking up the methods and let the API gateway handle CORS headers across the board, but for now this is all we have available. The API gateway has populated the list of methods it will allow. You can't modify this right now because of the any method that's underneath the proxy. Next you have the list of headers. The default list is fine. It covers all the basic headers that we might care about for authorization and for content type negotiation. You can scroll through there if you're curious. And after that we have the allowed origin. Now for now we're just using a star, but that's not as secure as you might want it to be later. But for now, good enough. And under the advanced section, you can set the exposed headers, the max age, and whether credentials are allowed like we talked about. We don't need any of these things for our application, so we're just going to leave them blank. So let's go ahead and click Enable CORS, and replace existing CORS headers. And we'll get a dialog showing what's about to happen exactly. Double check it if you so desire, but we're just going to hit Yes and replace existing values. And now we just wait for the check marks to finish. That wasn't so hard. So now if we click on the new options method here, under integration request, you can see that the type is now mock. Now since the response is static right now, the API gateway just treats it like a mock response. And we're done. That's it. We have now enabled CORS for our API. Congratulations. Wasn't that hard, right? It's kind of a complicated concept understanding how it works and what it does, but actually setting up, not so tough.